A function, represented here by a box, is a relationship between a set of inputs and a set of outputs. We put stuff into the box, perform a series of operations, and get stuff out. For example, the cube function takes the input x equals 2 and returns the output y equals 8. We could draw a graph representing this function. The input is shown on the horizontal axis and the output is shown on the vertical axis. The two expressions shown here can both be used to mean a function f that is applied to an input variable x. By way of example, we might define a function f that takes two inputs, x and y, and simply multiplies them together. Let's have a look at a more abstract example. This is Beyoncé and her sister Solange. In a sense, we can think of sister as a function here that defines a relationship for the set of values Beyoncé and Solange. The same notation can also be used for the composition of two functions. We write g of f of x, where function f is applied first. Here's an example. Suppose now that we know the result for x cubed and we want to find x. We could do this from the graph by drawing a horizontal line at y equals x cubed and reading off the value of x from the axis. Let's construct a function that does this in general. We'll call it the cube root. To draw a graph of the cube root, all that we need to do is swap x and y on the axes. This is equivalent to a reflection in the line y equals x. It is not the same as a clockwise rotation by 90 degrees, which would put the x-axis facing the wrong way. We could say that the cube root is the inverse of the cube function. Loosely speaking, the inverse, which is written with superscript -1, is the operation that takes us back to where we started. In ordinary algebra, the reciprocal 1 over x is often written as x to the power of -1, to indicate that it is the inverse of multiplication. But consider what happens when x is equal to 0. We need to consider the sets of inputs and outputs that our functions are designed to work with. The set of inputs is called the domain, and the set of outputs is called the range or the codomain. A function is a mapping between the domain and the codomain. In mathematical notation, we write that f defines a mapping from set x to set y. For instance, in the case of the cube function, we may take x and y to be the set of all real numbers. For the reciprocal function, we might define the domain to be the set of all real numbers excluding 0, to avoid problems. For Beyoncé and Solange, the function's sister is self-inverse. However, we now suppose that Beyoncé and Solange have another sister, Estelle. Now there are two possible results when the function is applied to any of the variables. You may have heard this type of situation referred to as a many-to-many function, but this is a misnomer because a function must return a unique output to avoid ambiguity. This is also true for functions in computer science. For another example, we will consider the square root function. Given the input 4, what would the output be? Since the square root is the inverse of the squared function, we reflect the graph y equals x squared in the line y equals x. However, this gives two possible results for the square root of 4. So that the square root defines a proper function, we take the positive branch. We can define the square root as a mapping from the positive reals to the positive reals. Whilst one-to-many mappings are not permitted to avoid ambiguity, there is no issue with many-to-one mappings. For example, the squared function which maps the set of real numbers to the set of positive reals is valid since every element in the domain is mapped to a single element in the codomain.